All right, so starting on page 459, today we're going to talk about something called matrix multiplication.
Oh, no.
And I know that some of you, the secret's gotten out a little bit about calculators, but I am going to ask you to do matrix multiplication by hand today for the reason that calculators can't handle matrices, but when the elements are, instead of having numbers right here, sometimes those elements are variables. Like you might see a W right here, or a 2x, or a 3y. When those elements are variables, then your calculator will work as well. And you know who likes to put variables in their matrices?
ACT.
Standardized tests. They love it because they want to see, not can use a calculator, but do you understand how a matrix works? Abdullah.
Didn't you say you were going to teach us on the calculator how to cut the matrix?
I will. Next class.
Oh, no.
So today we're doing stuff by hand, okay? Now, we are on page 459, but we're not going to do this example. We're just going to take some notes. So to be able to multiply matrices, the first thing you need to be able to do is identify the dimensions of a matrix. So do you feel like you can say, okay, this matrix has 2 rows and 3 columns? Good. Because in order to multiply matrices, you have to make sure it's possible first. So let's take some notes right here. To multiply matrices, here's what we do. We're going to multiply the row of the first matrix by the column of the second. So I'm not going to lie, multiplying matrices is a little bit weird, but here's how it works. We're going to be multiplying rows. We're going to be multiplying a row of the first one times a column of the second one. I'll show you how all that works out in just a minute. Now, it's really important, since we're multiplying a row by a column, there's some criteria that has to be met in order to be able to multiply a matrix with another matrix. So if I'm going to multiply matrix, let's say I have a matrix that has dimensions m by n. And I multiply it by a matrix with dimensions n by q. In that order, because with multiplication of matrices, the order does matter. So we're going to do the row of one by the column of the other. So it does matter the order. It's really important to be able to multiply matrices that the number of columns, oh shoot, I think I did that backwards, of the second one matches the number of rows of the first one. We switch that. Multiply the column. Hold on. Let me pause for a second. Multiply row by column. No, just kidding. I was right. Don't erase. Yeah, columns have to match the number of rows. Those two numbers need to be the same. Other thing that is going to happen, if I multiply those two together, they're going to give me a matrix with dimensions m by q, which comes from the outside parts. So the m and the q, that's where that comes from. Now that sounds a little bit weird, right?
Yeah.
Okay, so pause on that thought. I'm going to give you a real life example, and I want you to just try to come up with an answer, not thinking about matrix multiplication, and then we'll put the two together. Okay, so just like forget this for a second, and then we'll come back to it. So go to page 465 and look at problem 18. Page 465, problem 18.
Mhm.
Problem 18 has two different matrices. First matrix gives me information about what?
Snack bar A.
So I've got snack bar A, snack bar B, snack bar C. I have menu items: fish tacos, veggie burgers, and chicken teriyaki. What are these numbers inside? What more, Vin? Quantity. Yeah, because it says it's the inventory. So
Oh, that's
how many veggie burgers does snack bar C have?
19.
19. Snack bar C has 19 veggie burgers. How many fish tacos does snack bar A have?
20.
20. How many chicken teriyakis does snack bar B have?
8.
8. So we understand that matrix?
Kind of.
Like what's in there? Okay. The second matrix is the menu matrix. What's happening in the menu matrix?
Which was
Prices.
B.
So fish tacos cost $10. Chicken teriyaki, 12. And from there, right?
Mhm.
So we're gonna think, okay, we've got 3 different snack bars. They must all be the same different company because they're charging the exact same price, but they're just different locations. Okay, so my question that I want you guys to figure out, you don't have to worry about multiplying matrices, just figure this out. If each snack bar sold all of its inventory, how much money would each snack bar have? Would each snack bar have?
Oh.
So try to figure this out.
Easy peasy.
Which means how many numbers am I asking you to find? 3 numbers. I need 3 numbers from each of you guys. Would each snack bar have? Thank you. Then when you figure out how much money each snack bar would have, ask your neighbor or the people around you, hey, what did you
Do something.
Anybody want to say how much snack bar A would have?
435.
Snack bar A, $435.
Yes.
430.
Snack
four-
bar B,
$430.
And C is 345.
Yeah.
so snack bar A, $435. Snack
Yes.
bar B would have 430. Snack bar C, $345.
Mm-hmm.
Okay? To get these numbers, what did you have to do?
Multiply each one.
Multiply.
You multiplied. So let's just take the number 20. What did you multiply 20 by?
10.
So you multiply 20 by 10 for snack bar A. Then you multiplied 15
5
by 5.
10 by 4
And then you multiplied 7
by 4.
by 4.
12 by 11.
And then you multiplied 12 by 11.
Mm-hmm.
Then what'd you do with those numbers?
Then add together.
Add them all up.
Mm-hmm.
And you got 435 for snack bar A.
Mm-hmm.
So in other words, didn't you just multiply a row by a column and get a number? Yeah? And then for B, you multiplied a row by a column and you got that?
We've been tricked into doing. We've been tricked into doing.
So you said matrix multiplication was weird, but you just did it. And that's how it's done. It's just we have to be careful about how, like, whenever you do matrix multiplication, where you write your answer goes in a specific spot. So we just be careful. We just need to be careful about where we put those things. So let's do this with matrix multiplication. Now we're not going to do the one right beside it. So if you need to use some of this space to carry your work in there, let's do it. We already know the answer, so it's kind of like watching a movie, a historical movie where you already know the ending. But let's focus on the how we get there part. All right, so I'm going to multiply this matrix by the menu matrix that has 4 numbers. 10, 5, 4, 12. Where am I getting these numbers again?
From the menu.
From menu.
Yeah, from the menu.
Seemed like a trick.
Okay, so let's check the dimensions. This is a, what are the dimensions of this matrix?
3 by 4.
Yeah.
This is a 3 by 4. This is a,
4 by 1.
this is a 4 by 1. So am I allowed to multiply the two matrices together?
Yes.
Yeah.
Yes, because this 4 is the same as that 4. They match. Okay, and I'm going to end up with what, Delaney? A 3 by 1. So because the outside parts are 3 by 1, I end up with a 3 by 1. I'm going to multiply those together. I'm going to get something that has 3 rows and 1 column. So I'm just putting blanks there. Okay. We need to do some work. Maybe I should make mine a little bit larger. Doing things the wrong way here. 1, 2, 3. Okay, so you guys said earlier you multiplied row 1 by column 1.
Yes.
Yes? Okay. Well, when I multiply row 1 by column 1, that's going to give me element 1, 1 in my resultant matrix, my answer matrix. Row 1 times column 1 gives me element 1, 1. So to get this number, you did 20 times 10, right? So 20 times 10. This. Whoa. You okay back there, Christopher? 20 times 10 plus 15 times 5 plus 7. My sleep is making my board move. 7 times 4 plus 11 times 12. And that's how we got, what was it, 435?
Yes.
Okay. Then we multiplied row 2 by column 1.
Do the exact same.
We did 10 times 22, 18 times 5, 4 times 6, 8 times 12, and we added them together and got
430. 430.
430. And by the way, I multiplied row, which row?
2.
Row 2 times column 1, and that gave me element in the row 2 in the first column. And then finally, there's a 5 there. We multiplied row 3, column 1. Gotta have to tuck this, leave it. Row 3, column 1. We got the element row 3, column 1. So we did 15 times 10, 19 times 5, 10 times 4, 5 times 12. We added them together and we got
345.
345. That's matrix multiplication. Ella.
Will there ever be 2 columns in the?
Yes. We're getting ready to do one like that.
Oh yeah, I saw.
Nick
one
or
of those
Sam,
on-
who had their hand up? Was that your question? Okay. Yes, we will do that. Will there ever be 2 columns? Yes. Let's add that in example 1. So go to page 460. Come on now. Example 1. Now, example 1 is about Oscar and grades, but we're going to change that example to just being multiplying matrices. So we're going to mark this out,
Make a new.
make a new problem. Let's do let's multiply a 3 by 2.
You're fun.
I know, times a 2 by 2. Thank you, guys. Okay, Christopher, if it rings again, answer the phone. Same as honey, that's where student speaking. Okay, thanks. It rang 3 times. What am I'm not teaching? Come on. Alright, let's see. Can I multiply 3 by 2 times 2 by 2?
Yes.
Yes. Okay, so let's
We'll
do
do
it.
that.
Let's make one up. 1, 3 by 2. 0, 2, -1, 4, 3. 3 rows and 2 columns. Times 2 rows and 2 columns. -2, 5, 0, 4. And multiply those together. What am I going to end up with when I multiply 3 by 2 times a 2 by 2?
3 by 2.
I'm going to end up with a 3 by 2.
Yeah.
3 rows, 2 columns. wanted to know if I multiply, let's go out of order here. I multiply row 2 by column 1. If I multiply row 2 times column 1, that's going to give me the element in row 2, column 1. That's going to give me this element right here. Row 2 and column 1. So let's find it. 2 times negative 2 plus negative 1 times 0. Negative 4. Okay. Now if I multiply row 1, which column you want to multiply by?
2.
Okay. Row 1 by column 2, then I'm going to get the element that is in row 1, column 2. That one right there. So 1 times 5 plus 0 times 4 is 5 plus 0, 5. Okay, let's take off those highlights. Do the negative 2. And this was a, what's the number was this?
5.
5. Okay. Now let's multiply, which row? What do you want to do?
Row 3.
Row 3. Which column?
1.
Column 1. So if I do row 3 by column 1, that gives me the number that's in row 3, column 1. Zeros make it things nice. 4 times negative 2 plus 3 times 0. That would be negative 8 plus 0, negative 8. You guys find the other 3 elements. I'll highlight 2. Multiply row 1 by column 1. You get element 1, 1. So for element 1, 1, I'm going to multiply 1, 1, row 1, column 1. So I would do negative 1 times negative 2 plus 0 times 0 is negative 2 plus 0 is negative 2. Did you get negative 2? Okay. Let's do, I see a couple of blanks. So let's do this one. That's row 2. So row 2 by column 2. That one. I'm coloring with my mouse. It's really fun. Okay. Row 2 times column 2 means I'm going to take 2 times 5 plus negative 1 times 4. So 10 minus 4, 6. And then for the last one, it's row 2, column 2. So row 2.
Or row
Row
3,
three.
right? Yeah.
Sorry, row 3,
I was like,
column 2, which means I need to multiply row 3 by column 2. So I'll do 4 times 5 plus 3 times 4. 20 plus 12, 32. Matrix multiplication. How's that?
confusing at first, but it makes a little bit more sense.
Is it easy to make a mistake in there?
Yes.
Yes.
Yeah.
A lot.
So when you do these on Delta Math, it starts off being guided. And at one point it'll tell you, well, your number in row 2, column 3 is wrong. So it'll tell you to fix that number before you have to submit. All right, let's try whenever we have matrices that have letters in them. So look at example 3. It's on the next page, page 461. Here we're multiplying a 2 by 2 by another 2 by 2. These are also called square matrices. Think you can do it on your own?
I'd be okay.
See if you can beat me. Go.
Beat
You're
you.
your math teacher.
I'm
Yeah,
going to
you
do
said
it
you
really
wanted to
slow and I'm going to show all my steps. So see if you can beat me.
Okay, so a little bit this.
Am I messing you up by talking to myself?
Kinda.
Oh, I'm on the last one.
I got it. I'm done.
2, column 2, 0. I'm done. I got A, B, C, D.
Wow.
Same.
So
Same.
Same?
Hey, alphabet.
Whoa. Wait a minute. What is this answer?
The same as the first matrix.
Oh, what's going on?
This is the multiplying thing, right?
Yeah.
It is
yeah,
the
this-
multiplying thingy. It is called the multiplicative identity.
101, 1001.
Yeah. What? Like 1 second. Because I know what an identity matrix is. So I'm like, oh, that's ABCD. And so now you'll be able to as well. Okay, so here's the thing. You know, with multiplication of just numbers, not matrices. Whoa. I ran into the board. 5 times 1 equals 6 times 1 equals
6.
x times 1 equals
X.
x. So anything times 1 is itself. That's called the multiplicative identity. 1 is our multiplicative identity.
Did you just say?
Meaning, in multiplication, anything times 1 is going to give me that same thing. That's what 1 does whenever you multiply. Well, with matrices, instead of having one number, we have a matrix. So if I want to multiply a matrix by something else, and get that same matrix, I need to multiply it by the identity matrix, which is 1001. This is called identity matrix. Christopher.
Could be 0, 1, 1, 0.
No, it's got to be ones and zeros from left to right. Other identity matrices,
Negative
because
1.
this is a 2 by 2 identity matrix. This will only work whenever I multiply a 2 by 2 by the identity matrix, yes. A 3 by 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1.
The identity matrices only have the matrix as a square.
Yes, the matrices have to be a square to have an identity matrix that you can multiply by. Abdullah.
How do you find, like the first two on the left, how do you find the other two?
What do you mean by first two on the left?
Like, if you know 1 and 0, and then you do A and C, and then you do 0 and 1, and B and D, what do you do after that?
To find
The third and the fourth. I mean the ones on the right. How do you find
this column?
Yeah.
How do I find this column?
Uh-huh.
Whatever I multiply, so this is element in row 1, column 2. So I would multiply row 1 by column 2 to get B.
Okay.
And then this is element, right here, that's element row 2, column 2. So I'd multiply row 2 by column 2 to get that.
Thank
So whatever number element that is, that's the row and column that you multiply. Alright. So identity matrix, you can identify it by if it has ones and zeros and the ones are going left to right. Yeah? We need to know about identity matrices because they'll be handy for solving a system of equations. You just need to know it there.
Okay.
How do you feel about matrix multiplication?
I
Okay.
feel okay.
Okay?
Okay.
You'll have some practice.
Yeah, I feel
If you
better.
show
once
us
I
the
do it.
decimal streak, that would be awesome.
I know we're not. Well, I'll show you next time. Okay, so I'm looking at our list. You can identify dimensions. You can determine two matrices can be multiplied. You can multiply. Now we need to talk. Can you recognize an identity matrix?
I guess.
Yes. Now we need to look at determinants and inverses. That's in 10.4. So flip it a couple of pages to 10.4.
And that's
10-4. It's on page 475. Did you find page 475? Okay, flip to page 476 because we're not going to write anything on 475. I wanted to show you where it started. Okay. So this is about inverses and determinants of matrices, and we need inverses and we need determinants in order to be able to solve a system of equations, which is why we're studying matrices. So today you'll learn how to find these. Next class you'll apply them to solve the system.
What page is this on?
470. This is 475, but we're going to write down stuff on 476. So today, whenever I ask you to find an inverse and then a determinant, and you're like, why do I need this? You're not going to know until next class. Just know how to find inverse, know how to find the determinant. All right, so on page 476, right beside example 1, it asks us to find the inverse of the matrix. Like, what is an inverse? Let's define it. I can find my pen. All right. How do I want to phrase this? An inverse matrix is a matrix you can multiply by to get the identity matrix. it would be a matrix that kind of undoes another matrix to give me an identity matrix. Now, we know that an identity matrix, Christopher, what did you say about identity matrices? What did you say? They can only be what shape?
Square?
Squares. Identity matrices are squares. So to find an inverse is also needs to be a square. So not every matrix will have an inverse. Connor, a rectangle. Like a square matrix is the rows and the columns are the same number, so like 2 by 2, 3 by 3, 4 by 4. Say that again. For an inverse matrix, you have to have a square matrix. Yes. Yes, there are no like triangle matrices or circle matrices. Right.
Can you have undefined spots in a matrix? Spots that aren't zero or a real number.
You have an undefined spot. What makes you ask this question?
Asking about matrix, if there were matrices that weren't rectangles.
I'm thinking about what would cause something to be undefined, and that would be dividing by 0. And with matrices, to avoid dividing by 0, we don't divide matrices. So if it is a matrix, then it shouldn't have an element that is undefined. We can have a whole matrix that's not defined. As far as elements go, for right now, I'm going to say no.
Also, so if you have a matrix that has 11 rows and 11 columns, how do you write it in the notation?
Probably with a space in between the two 11s,
Yeah.
or a comma, or an R and a C.
Yeah. I've seen that before.
Yeah. There would have to be something, because otherwise it's really like 1 row and 11 columns. Yeah. Yes, Abdullah.
So if there's more than more than 2 rows or more than 2 columns, do we just add the 1 after we multiply? Or
Are you looking at a specific problem?
yeah, like the one we did, like if there's like 3 columns and then 3 rows.
Okay. You're asking about multiplying this?
Yeah.
In the answer matrix, whatever element number that is the row and that's the column that you would multiply by.
Oh.
So if it's element 2, 3, you would multiply row 2 by column 3. Alright, so inverses. This is an inverse, you multiply a matrix by its inverse, you get the identity matrix. Good there? Okay. We're told to find an inverse, but in order to find an inverse, we need something called a determinant. So, right. We need something called a determinant. Which is a scalar number, which is just a number, to find the inverse. And there is a formula for the determinant. If matrix A is defined like A, B, C, D, then the determinant of A, which is DET capital A, you find it by taking A times D, element A times element D, and subtracting B times C. So there's going to be a matrix, a 2 by 2. You'll get a 2 by 2 matrix. There's a number where the A is, a number where the B is, a number where the C is, a number where the D is. To get the determinant, we're going to multiply these two and subtract the product of those two. Okay, so let's try finding the determinant on example 1. Zoom out. There we go.
3 minus 5.
So this determinant, I take this product, 1 times 3,
3 minus 5 equals 3.
minus 1 times 5. And that's bad notation on my part. That should be DET. And what did you get? 1 times 3 minus 1 times 5?
Negative 2.
Negative 2. Okay, we found the determinant. All right, find the determinants for example 2, A, B, and C, and we'll come back and do inverses too. Oh, not C. We don't have to do 3 by 3.
You don't
We
have
just
to.
have to do 2 by 2s. I got 0 for the determinant of P, and for the determinant of Q, 1. 7 minus 6, 1. You're okay with finding the determinant? Okay, it's a formula, so just practice using it. Now, if the determinant is not, if the determinant equals 0, the matrix does not have an inverse. So in example 2, which of those would not have an inverse? A, no inverse here. Now you ready for the formula to find an inverse? Here it is. Get ready. I don't have it memorized. And you won't have to memorize it either, but here it is. You will have to use it. So the inverse. Did I define that matrix as matrix A earlier? The ABCD one?
Yeah.
Okay. The inverse. The notation is the capital letter, the same capital letter that you would use, the inverse matrix. It looks like a 2 to the negative 1 exponent, but that's just notation for the inverse. You're going to take 1 over the determinant times, and then you got to do a little switcheroo of these elements. D and A are going to switch places. And then opposite of B, opposite of C.
That's like find the inverse.
That's how you find the inverse of a 2 by 2.
Okay.
It gets even weirder for 3 by 3s, but we don't have to do 3 by 3s by hand. All right, do you have that formula? Because we're going to find the inverse here. We need to erase these marks. Do that. All right, let's find the inverse of the first one. I'm going to take 1 over the determinant, so 1 over negative 2, times, I'm going to switch the 1 and the 3, and then I'm going to make 5 and 1 opposite, so negative 5, negative 1.
Mm-hmm.
And then I multiply that negative 1/2 to everything. So the inverse matrix Negative 1/2 times 3 is negative 3/2. Negative 1/2 times negative 5 would be positive 5/2. Negative 1/2 times negative 1 is positive 1/2. Negative 1/2 times 1 is negative 1/2. This is the inverse.
Can we just write decimal?
Wait, so we can do decimals and fractions.
So you want to do negative 1.5 instead of negative 3/2?
Yeah, they could do
Yeah.
one.
That's fine. Is that okay?
Well, I guess it depends on what the
Okay.
question's asking for. If it asks for like fraction, then
Yeah.
do fraction. But that's what it's-
All right, see if you can find the inverse of matrix or 2b. Example 2, part B. Inverse of Q.
Oh, easy. Nice.
And then you can look up to check and see if we have the same thing.
Yeah. That was pretty straightforward.
I got 1, negative 3, negative 2, 7. All right, so our goal for today was to multiply matrices.
Wait, that was 1, negative 2, negative 3, 7.
1, negative 2, negative 3, 7. You don't switch these places, you just change the signs. Oh, Emma is the one who said that. Right.
Why isn't it negative 1, 3?
Why I heard the y isn't the negative 1.
Why isn't it negative 1, 3 to negative 7?
Negative
Because
1.
it's then you don't put negative for A and B. You just switch it.
Yeah, A and B just use A and D switch places.
Oh, I'm sorry. I thought it was negative 1.
Yeah, just one over the determinant.
Is that it?
All right, so can you multiply matrices now?
Yes.
Can you find the determinant of a 2 by 2?
Yeah.
Yes.
Can you find the inverse of a 2 by 2?
For the most part.
Okay. That's what your homework is about.
Oh no.
And we have what?
How many questions on the homework?
I don't know. I can look. Hold on.
Wait, what are we doing for part B of the